How many times have you heard teachers share their frustration that, my students just are struggling with computation? It's like
Hmm.
just the four operators, we're adding, subtracting, multiplying, dividing, and the algorithm isn't working for them. A lot of inaccuracies. Students are coming up with answers that are not even reasonable.
Yeah.
And then they're asking themselves, and we look at the solution and we're like, does this even make sense?
Yeah.
And the student's like, I have no idea if it makes sense because I just followed the steps.
Sure. That's that's a main problem. I think that here's the next problem though, right? We want then to say like let's not focus on the algorithm, let's focus on strategies and maybe making use of models. But I've tried that.
Yeah.
I've tried, the multiple approach, but that might be even more confusing. And therefore I should just stick to one thing. Like let's just give one solution. Like you recognize this is the problem, do it this way. Because at least then I've given them the one way to solve that. Because I feel like giving them too many options is confusing students.
I actually just heard this last week from a teacher. That was
Right.
exactly their reaction, right? It's like, well, if the algorithm isn't working for you and it's not working for your students, and your students are coming up with answers that are unreasonable, maybe there's another way to approach that computation. And you're right. The first reaction was like, oh, I've tried that. And it
Mm-hmm.
just gets messy and it's confusing. And if they can't, master one approach, how am I going to get them to own more than one?
Right.
So now imagine you are the instructional leader in this building. And so, you've identified, and the staff agrees, your teachers are saying, yes, we want our students to have increased computational fluency. We want them to be accurate when they're working with all four operators. We recognize that maybe for some, the standard algorithm approach is not working, but we're also reluctant to
Yeah, we're not
teach
convinced.
more strategies. They're not convinced.
Yeah, we're not convinced that the more is better approach. The optionality isn't the better approach. It's louder, stronger, and more repetition of the first approach. That might be the ticket because it worked for me, it worked for us, but that's easier than trying to do, all the other stuff because it'll just confuse them more.
We're working with a principal right now. And what was really, I think, amazing about this particular site is this identifying the problem that they wanted to solve was actually pretty easy for this staff. They came to a pretty quick consensus that, of course, they would all like to see their students increase their mathematical fluency as defined by working flexibly with all four operators based on what's appropriate for their grade level. Where they're struggling is on the solution.
Mm-hmm.
Agreeing or committing to a strategies based approach. And so this principal is now in the position where I don't think she's confident to move forward with the solution until the teachers themselves have some mathematical epiphanies around the value of maybe having more than one way to solve a
Right.
problem.
And that's typically what you're saying is typically the recommended solution that we talk about our teams with is when we are seeing resist. I tried that approach or multiple strategies approach, or I think the one way is the best way. How do I help my teachers see that being flexible is a better skill or a more worthwhile skill to have as a student, but also as a teacher, than trying to just memorize the one way. Because that's typically what these barriers are, is that we know that this is better for our kids in the long run, but it's hard to kind of get over the hump, I guess. What does that look like? Like, how do I support? And the supporting, our recommendation is this is what you're helping this team with, is to say, like, how many, like, we have to help everyone with more access to like have those math epiphanies. Like, what are
Mm-hmm.
some of those the strategies that they don't have? Because if I'm saying I think the one way is the better way, it's just likely that I just haven't had the confidence around all the other strategies to create the flexible superpower that I could have. And
Mm-hmm.
if I spent time supporting educators to create that and embedded it into any sort of collaborative time we have together, then down the road they'll have, like, it'll be like through no fault of their own, all of a sudden they'll have these strategies to rely on, and that is the convincer, right? Like the convincer isn't like just do more of it. The convincer is like you've got to build their capacity up.
The advantage that this particular site has is that they are willing and able to commit time every week to this work. So they meet as a staff weekly, and
Okay.
a portion of that staff meeting every week is reserved for math because math is a
Good for
priority
them.
at their site. Yeah, it's awesome. They come together as a full staff. This is a K-5 school. And so where we started with this team is we had to start to shift belief and shake up a little bit of the resistance. And so we started by engaging in some webinars together, watching some videos, and we used an ICQ protocol, which is essentially something that confirms my current belief and something that I'm questioning. So it leaves space for people to say, I don't believe this, or this, I'm not convinced of this. So we've created 2 opportunities so far. The first one was we had them engage with Jennifer Bay Williams' session from the summit, where she basically talks about, I want to say in the first 10 minutes, it's like she pretty bluntly says, the ways that sometimes we try to say students are going to build their fluency, through rote practice and memorization is just, the research does not back that.
Right.
And I think sometimes people need to hear that from somebody other than their instructional leader in their building. Somebody that's respected in the math community, and again, with space for them to also push back or challenge.
That's right.
Like this was not a space where it's like, let's watch this webinar and everyone needs to agree.
Yeah.
It's just an opportunity to begin having some discourse and to maybe start questioning if the way that we were taught or the way that we're teaching is actually getting us the results we want for students, and maybe opening our eyes to the possibility of there being another way that we hadn't yet considered. I also really love, there's a YouTube clip from Christina Tondevold, and we'll link it in the show notes. The clip itself is actually about the difference between procedural fluency and conceptual understanding. But in this 10-minute clip, she talks about some really great examples of where the standard algorithm fails us, where it's just super ineffective. And so she does, of course, the 1,000 minus 999 stacked standard algorithm. And it's like, wow, if I use the standard algorithm to solve that problem, and I can't just see that it's 1.
Yeah.
Like, that is such an inefficient way to approach that problem, and really shows a deep lack of understanding of the behavior of subtraction. The other example she gives in the video is she talks about going into high school classes, and students have to subtract 17 minus 9. And so they write it 17 minus 9 stacked, and then they borrow the 1 and they still have 17 minus 9. It's like we're no closer to an answer, right? Of course, because we're blindly following. Right.
You just didn't do it enough.
Right. We're blindly following these procedures that really aren't helping us get to an answer. And so that's where we kind of started, was we just needed to shake belief a little bit and create a space for dialogue where we have a conversation starter about maybe the standard algorithm isn't always the best way to approach problems. And wouldn't it be amazing if students didn't get stuck in these traps of being very inefficient or coming up with very inaccurate answers because they don't know what they're doing?
Yeah. Yeah. What I love about what this team has done, because if we think about the high level in terms of math improvement planning, because that's really what's happening here, right? Is that we've recognized that there needs to be a shift towards making sure that there's fluency strategies happening in our classrooms, and multiple strategies that are a priority for where we're trying to go. Therefore, I need to make that shift in our classrooms, or we need, as a collective group, need to make that shift in our classrooms. And instead of just saying, this is where we're going, here's what we're going to choose a curriculum and we're going to stick, that follows this and do this and follow this with the pacing guide and go down this route. It's they unpacking and taking into a consideration some really big elements of what you need to include for math improvement planning, which is, one is realize that the barrier to most shifts is the content knowledge for our educators, in the unfamiliarity of multiple strategies, multiple models, and what say models stretch vertically, which ones we need to rely on more than others, which strategies we could be helping with, like our students with, like coming at it from the conceptual towards the procedural, like just having that fundamental belief shift happen, but also supporting that shift in terms of the educator's own capacity building around their own mathematical thinking and their own mathematical proficiency. We just don't have that, We don't have that familiarity that we need our educators to have. And it's not their fault. It's we came through a system that just didn't, teach math. And we still consistently don't teach math that way. And we need to teach it to our educators or give them experiences. So I love that they're focused on that. But the other thing I really love is as another big picture element. Like we got four big, problems we solve with our teams. And one of them is obviously building capacity and making sure we're focusing on that. The second one that they are doing a really great job on is making use of their subsystems for instructional improvement. Like you're saying the priority here is to create epiphanies for mathematics so that it will translate into instructional practices down the road or even now. But we got to make use, like, because we recognize a priority, we got to find the time, because it's like, oh, we don't have time to do that. But it's like, find the time. Like the fact that they're meeting every week to do this type of work, it means I put the priority here. I've decided this is the priority. We're going to come together to do more math together as a priority. We're going to make use of that collaborative time in that way. We're not going to treat this like, all the logistics that we could be going over and all the stuff that could have been an email. We're actually going to use this time to do this type of work because it's going to lead us down this pathway. And I can see what the future will look like if we stick to these two things: focus on math, make use of the collaborative time to do it.
I remember when I first met with this leader, that was one of her hesitations, I guess, is that she didn't feel she had support or subsystems. So she's a single administrator, no coach, no lead teacher, no math it's a single administrator building, and they don't have any embedded teacher collaboration time or PLCs. And so I think when this journey began, she actually was concerned about not having the right supports in place or having the subsystems, but the fact that, like you mentioned, she is committed that, okay, the one system we do have is staff meetings. We have a staff meeting every Wednesday. She's committed that, like you said, any of the logistical things that would be monopolizing that time are being put to the side, sent in an email, addressed very quickly so that they can carve out. And sometimes they actually dedicate the whole hour to math. It's minimum half of the time, but most times it's actually the full hour that they commit to this learning because it is a priority. And their data, their benchmark assessment, their standard state test assessment suggests that there's a critical need in math. And so this is how they are dedicating their professional development time this year. I also understand too that at the elementary level, math is often not the only priority, right? So it's challenging. Like it certainly is, but I think that they've done a really good job of saying, we know we can't tackle everything at once. We don't have the capacity. We don't have the systems. So this is the one we're going to commit to right now. And we're going to go all in. And we're going to use all the time that we possibly can. I'm excited for this team's journey. So I'm picturing, I work with this principal and we come together after every staff meeting. We reflect on what emerged and then we plan. So we always gather some type of exit ticket, or she does some anecdotal documentation to get a really good sense of where the room is at so that we can target the learning for the next session. And so what I obviously would like to get to with this team is that they are doing math. Right. So right now we've been mostly understanding the why or creating a space for dialogue. But now we need to get into a routine of every time we come together, we are building our own toolkit of strategies so that we are better positioned to solve problems that don't lend themselves to the standard algorithm with efficiency. The advantage this team has, though, the principal does have a math background. So I just want to put that out there for everybody. Right. Yeah. That's also a huge factor when it comes to this work at the school level.
Right. There's two conditions. Like, she has the two conditions that you really need at a school level to do this type of work consistently. If you're going to make use of those subsystems for support, like a staff meeting or PLC, is that, you've got a skilled facilitator who can lead individuals and can facilitate sessions and can rally the troops here. But then you also have an understanding of the progressions of mathematics. Like you have a solid understanding of like what is important in mathematics. Like you can decide, like you can have that what's important in mathematics, like fundamental core beliefs around learning mathematics, but you still need to have lead these sessions. Like you still need to be able to unpack, like when you're doing division sessions, like what does this division look like? What are the models? What are the strategies that we could really unpack? Let's grab our curriculum. Let's tie it to that. she's got that because she came with some of that math background prior to being in this role. And it's not always the case that your instructional leader has that math background. And I'll probably argue that typically that's not the case. But you do need, who is that significant other that can do that work with you, right? Like that's the duality that other teams have, or we try to encourage. If you are going to create that type of environment in a building or a system, that's the type of the dual role you want to strive for. um, the bigger system you have, the more people are involved, but you do at least need to have, say, at a school site, who is the instructional leader for math, and is that the same person as the facilitator that can keep the wheels turning in the right areas, in the right pieces, and use the right pieces to do it. So they've got some great things happening here. And if you zoom out a little bit too, is that this is one school inside of a larger system, where this system also has many schools working on similar goals, similar processes. So in Yvette, you said this is one, this, I'm working with this principal, but really this school system is taking part of our district improvement program. So we're supporting the entire district on improvement. And right now, the year that we're on with them is specifically helping instructional leaders at school sites develop appropriate school goals and make use of, say, those support structures in appropriate ways to help them achieve those goals. And that's some of the specific work we're doing inside this bigger system, while we're also meeting with, say, the system leaders to help design the other areas like vision and goal setting and sustainability, and making sure that the program doesn't rest on one or two people's shoulders, and how are you making use of distributive leadership, so we solve these types of problems inside this district. But specifically, that is paired with a number of schools inside the district to kind of do that boots on the ground school site support work as well. So that's the work we do on a consistent basis, is help teams, schools, school systems design math improvement planning, and what that looks like from a high level down into the school level. If you want to get a little bit more insight what this could look like for you, we have some space available. Head on over to makemathmoments.com/discovery. We can talk about your program soon.